Okay, so for the start, we have the string x equals parenthesis a plus b parenthesis times c is our starting string. So we're going to start with the parsing stack. We're going to start with the $ here, and we're going to start with our input, which is x equals parenthesis a plus b parenthesis multiplied by c $, right? For production, use semantic action and semantic stack. We'll use those later, but the semantic action is basically this on the right, which is semantic action. And the semantic stack is basically converting ID into like a variable in a sense, right? With x being like any number, like the number that we recently used, right? And we're going to start with 1. So for the parsing stack, we have nothing in the input. What we're going to do in the next line, I'm going to use dashes to keep track of this for me, so that it's nice and even for the lines. Next line, we have $ x, and then for the input is equals open parenthesis a plus b close parenthesis star c $. We're not going to use any productions here since none of the productions match these rules. Sorry, real quick, I forgot to go over the rules. So rule 1 is converting s to id, converting from id equals to e, and that reduces to s. All these rules, you can think of them as, instead of e1, to make it simpler, it's s going to id equal to e, right? Because you're never going to use these to determine the rules. It's just going to be generic, right? So for this one, it's just e plus e reduces to e, and then e times e reduces to e, for rule 3. And then rule 4 is rule 4 looks weird. Rule 4 is e with the brackets around it reduces to e. We'll see this later. But sorry, back to the parsing stack. So there's no rule that can be applied to x. Well, there is a rule, e to id, but we don't parse it now. We'll see that in the last step. It'll make sense then. It's a little weird, but it's just the way it's done. So the next step, we pop the next value, which is equals. And then we have the input, which is close parenthesis a plus b close parenthesis star c $. We don't use any productions because it doesn't match any. Next step, we have $x. We're going to pop another value, which is open parentheses, and then we're going to have a plus b star c $. That doesn't, what we have in the parsing stack doesn't match any rules, so we're going to not use anything, and we're going to push another one of the stack. So $x equals open parentheses a plus b close parenthesis multiplication c $. And there is a production here, right? A is our ID. So what we can do is we can reduce from an ID to E. And everything we do in this step happens in the next step. What you do in one line happens in the next. So even though we're performing this production in this line, wait, let me number these real quick. 3, 4, 5. Even though we're doing this production in this line, will only take effect next step. And same with the semantic stack. And for the semantic action, we have to label it. So we use E1 for now, since it's the first one we do. And then we can look up here, since this is rule 5 right here. Sorry, let me use a different color. This is rule 5 right here. This rule will also have this semantic action, right? So then here we do E1 equals make leaf, and then we use the ID, so A, and then semantic stack. We don't include anything here yet because in the next row it takes place. So we have row 6. We have $x equals open parenthesis E, and we don't pop anything yet. We just have the same stack. We have plus B close parenthesis multiplication c $, and then here we don't have any productions used. There's nothing here, but we do add the semantic action variable into the semantic stack, so it becomes E1 over here. And then the next line, we were to pop another value. So on line 7, we have x equals open parenthesis E plus, and then over here we have B close parenthesis star c $. And then in this line, we don't do anything because it doesn't match any of the rules we have above. So we cross this out. And we still have the semantic stack of E1 here that we had from the previous line. It still remains in the stack. So line 8, we have x equals open parenthesis E plus B and then close parenthesis, star C dollar sign. Oops, sorry, give me 1 second. There we go. And then here we do use Rule 5 again. So we reduce B to E. So the production we use is ID goes to E. And then for the semantic action, we do have to make a new variable here. So it's E2 equals make leaf B. And then here we push it onto the semantic stack. Oh, we don't do that yet. Sorry. We push on the row after. So right now the semantic stack would just have E1 here. Next row, we would perform convert B to E. So, oops, not row 9, or it's row 9, not 8, sorry. $ X equals open parenthesis E. Oops, haha. E plus E here. And then we have closed parenthesis multiplication C $. And since this does match a rule, this E plus E matches rule 2, right? Because rule 2 is basically E plus E reduces to E, right? And then in there we do E goes to E plus E. And then in here, we do E3, since there's a new variable being made, essentially. It's a little hard to explain, but essentially every time you make a new E, for any reason, it becomes it adds a new letter or a new thing in the stack and in the tree. But E3, instead of make leaf, it's make tree. So we can see it's right here in the rules. It matches rule 2. This is the semantic stack rule. So we do E3 equals, oops, where was it? Plus E2, E3. Okay, this is a little weird. So the stack, it'll look like E in this step. It'll look like E2, E1. And you'll think that it should be 2, 1. But since the numbers here are 2 and 3, you do the lower number first and then the higher number. I don't really know why. It's just the pattern that it is. So it is. So we do E1, E2. And since we push E2 onto the semantic stack, it takes place next line, and we'll see the E3 or E2 and E1 being reduced to E3 in the semantic stack in the next line. Next line we have 10 $ X equals open parenthesis E close parenthesis star symbol C $. Here we don't see any productions here because there's nothing here, but we do see a change in the semantic stack, which is now E3. Cool. Line 11, we have, we push onto the stack again, or we push onto the parsing stack again. So we have X equals open parenthesis E, close parenthesis, and then in the input, we still have star C $. And then here, parenthesis E parenthesis matches one of the rules. It matches rule number 4. Rule number 4 here. So we're going to perform this operation, and we're going to make another variable, right? So the rule would be E going to open parenthesis E close parenthesis reduces to E. So we have E4. We can see the semantic rule here, or the semantic action here. E goes to E2. So E equals E3. There we go. And then in the stack here, it doesn't update yet, so it's still E3. And then the next line, 12, we have X equals E. And then we have star C $. We don't have anything here, but the semantic stack does update, and now it is E4. Next line, we push onto the stack. We have 13. We have X equals E star. And then we have in the input we still have C $. Here we can't reduce anything, so it still remains the same. It's still E4. This looks a little bit different. What is it? I just want to make a note real quick. On this example up here, this says E4 in the answer key. I'm not sure which is right, technically, because he never taught us this. I'm just going based off this pattern. Do whatever you think is right. I think E3 is right, since that's the pattern everything else follows. But if you want to put E4, it's up to you. Okay, sorry, back to this. 14, we have... we're going to push on the stack again since it doesn't meet a rule. X equals E star C $. The rule we can do here is reduce ID ID to E. So E goes to ID. And then we make another variable for this. E5 equals make leaf. And then we have to put the ID here, so C. And then we still have E4 here. And the next line we do 15, X equals E star E, $sign. We do have another rule right after this, which is E reducing to E times E. So we would have E6 equal to E equal to make tree. It would be rule number 3 up here. So it's E times E reduces to E, and then that's this make tree right here. So we have E6 equals make tree, and then we do the symbol first, and then we do comma, and then E4, comma E5. And then here in the semantic stack, we have E5, E4, and it goes great. It goes most recently used on the left, least recently used on the right. I don't know. That's just how it goes. I don't really know why. I'm just following the pattern. And this we have X equals to E right here, E $sign. There is a pattern here that we do. This is the final step. This is where I said in the beginning it would make sense now. This is rule 1, right? So we see ID, so ID equals E reduces to S. So this is the reason we didn't convert this X right here to ID. It's so we can use it down here to reduce it back to S in order to get like the accepting state or to finish parsing. So here it's like 2 different steps because there's 2 semantic actions. So the production here would be S, ID equals E reducing to S. And then here there's 2 different steps, right? So if you look at this semantic action right here on the screen, you see there's E equals make leaf ID, and then S equals make tree equals E1, right? So this is a little bit different from the other ones because the E make here is used in this E here, right? So if this is E9, E9 is the first E here, right? I'm just going to write this out real quick. It's going to take like 2 lines. So we have E7 equals make leaf for X. And then the second line, and that takes effects. This semantic stack is the effect from above, so it's just E6 here. And then there's like technically 2 lines here. I would call this just 17. Nothing changes here. It just stays the same. That's just what it is in the example. But S equals make tree equals E7, comma E6. And you do this because it's E7, E6 instead of E6, E7, because up here you can see E is referenced from the previous E rather than just 2 variables. So that's why it's 7, comma 6. And then here you update the semantic stack, E7, E6 right here. Oops, there we go. And then in line 18 is like the last line. The X equals E reduces to S, so we have S here. We have nothing in the stack, which is just the empty symbol. Nothing here. In the stack, we just have S, and that's the final state. And that's it. Quick things to note, again, reiterating. For step 2 up here, we don't, ID does not go to E because we use X down here to convert it to ID in this step right here. This needs to be ID equal to E. If it was E equal to E, that wouldn't satisfy rule number 1 right here. And then it wouldn't be accepted. It's a really weird thing. In my opinion, they should be written differently to make more sense, but it's